Welcome to our module on trigonometry. We begin by talking about how angles are measured. Angles can be measured in three ways: degrees, radians, and gradients. You are familiar with degrees. You know that there are 360 degrees in a circle. But why is it 360 degrees? Well, it's because of the Babylonians. The Babylonians had a number system of base 60. They used base 60 and not base 10. The reason they use that base is because 60 has many more factors than does 10. 10 only has the factors of 1, 2, 5, and 10. 60, on the other hand, has many more. You can divide 60 by the numbers 1, 2, 3, 4, 5, 6, 10, 12, 15, 30, and 60. So when they looked at the circle, they said they'll stick to what they know. And so they kept with that base 60 theme. They said, let it be 60 times 6, which is 360 degrees. The gradient was an attempt by the French to standardize everything that they measured. You know about the SI system. This was an attempt to standardize the angle measurement by making it hundreds as well. For the French and the SI system, they said they would make a right angle, one that is upright, 100 gradients, so that a complete circle would then be 400 gradients. Remember, in the SI system, they use a base 10, so 10, 100, 1,000, and so on and so forth. We will be looking today at radians. So let's start by the definition of what a radian is. The radian is defined as that angle which subtends an arc length equal to the radius of the circle. So if we have here a sector, like a pizza slice, if this arc length of this sector is the same as the radius of this circle that it is contained within, then we say that this angle here is 1 radian. And please note, we don't use a complete circle like we do for degrees. No, we use this little C symbol, which is what represents radians. Also, of note, 1 radian is approximately 57.3 degrees. Not exactly, but approximately 57.3 degrees. Next, we'll be looking at how we convert from radians to degrees and vice versa. So to do that, let's take a look at the complete circle. We know that the circumference of a circle is given by the formula 2 pi r. Next, as we normally do in math, let's make things easier by choosing some convenient values. Let's say we have a circle whose radius is equal to 1, or as we call it, a unit circle. Then our formula will become 2 pi times 1, which is just 2 pi. Now, a complete circle, you know, is 360 degrees. So we can say that 360 degrees is equal to 2 pi radians. If we take both sides and divide it by 2, we then get that pi radians is equal to 180 degrees. And this right here is the important part to remember when you convert from degrees to radians and vice versa. So let's say we convert 45 degrees to radians and pi over 6 radians to degrees. First thing you will do is you write down your conversion factor. 180 degrees is equal to pi radians. We want to convert 45 degrees to radians, so 45 degrees goes with 180 degrees. How many radians will that be? Well, we simply cross multiply and divide. 45 degrees times pi radians divided by 180 degrees. The degrees are going to cancel out, and 45 over 180 reduces to a fraction of 1/4, so our answer is pi over 4 radians. We'll leave our answer in terms of pi wherever possible. Next, pi over 6 radians to degrees. So 180 degrees is equal to pi radians. How many degrees will be equal to pi over 6 radians? We cross multiply and divide. So we have 180 times pi over 6 divided by pi. Radians will cancel as well as pi. And so we only have 180 times 1/6, or 180 divided by 6, which is 30 degrees. Next, we'll be looking at how to find the length of an arc and the area of a sector when the angle is given in radians. So remember that a sector is just, like a pizza slice, right? It is a fraction of the entire circle. What fraction is it? Well, it depends on the angle. Whatever the angle is, it's a fraction of a complete revolution, which is 360 degrees. The formula for the length of an arc is theta over 360 times 2 pi r, where theta over 360 is what fraction this angle represents of the entire circle, and 2 pi r is the complete circumference. As we just learned, 360 degrees is equal to 2 pi radians. So if we were to simplify our expression now, 2 pi and 2 pi, they cancel out, and we're just left with theta times r. So the length of an arc is equal to the angle multiplied by the radius, if this angle is in radians. How about the area of the sector? Well, the area of the sector is theta over 360 times pi r squared. Because, again, this is just a fraction of the complete circle, and the area of the complete circle is given by pi r squared. And again, we know that 360 degrees is 2 pi radians. Here, this time, the pi's cancel out, and we're left with 1/2 times theta times r squared. So, if we are given the angle in radians, it is simply 1/2 times the angle times the square of the radius. Now, let's get into an example. Alright, so now with this example, we are asked to find the perimeter and the area of this shape shown. So we have this shape here, which is bounded by two straight lines and this curve. This shape is a part of a square. This is 5 centimeters, that's 5 centimeters, 5 all around. This angle is a 90-degree angle, or in other words, in radians, it's pi over 2 radians. So how do we go about finding the perimeter of this shape? Well, we have to first remember that in general, perimeter is not a specific formula. Perimeter in general is just the total distance around. So when we look at this shape here, there are two straight edges and one curved edge. These two straight edges are the two sides of this square. So side plus side. And then the curved edge, that is the length of an arc, which we can find using the formula r theta, because we know the angle in radians. So these two sides are 5 centimeters and 5 centimeters. The radius of this arc is also 5 centimeters. The angle is pi over 2. So we'll have here 10 centimeters and 5 pi over 2 centimeters. We cannot simplify 10 plus 5 pi over 2 because pi is an irrational number. So we can just simply leave this as 10 plus 5 pi over 2 centimeters. Next, how would we find the area of this shape? Well, again, remember, area is not just a formula. We use formulae to help us determine areas, but it all depends on what the shape is. So when we look at this particular shape, what is it made out of? Well, when we look at it, you should see that there is a square overall with a sector taken out from it. So what is the area of the square? That is given by side squared. And from that, we will subtract the area of the sector, this quarter circle, which is given by 1/2 r squared theta. So our side square for the entire square would be 5 centimeters squared, which is 25 square centimeters. And then finding the area of this sector, we'll have 1/2 times 5 squared times pi over 2. That will give us 25 pi over 4 square centimeters. This would be our answer because we cannot simplify this. We can, however, tighten up the answer by factorizing what is common. There's 25 that is common to both, and so you would have 25 times 1 minus pi over 4 square centimeters. And with that, we come to the end of this lesson.